Most programmers are obsessing over the wrong part of AI. The flashy chatbot answer is not where the real battle starts.
Right. The big split is training versus inference. Training is how a model learns patterns. Inference is what happens when you actually use that model to get an answer.
So one builds the brain and the other puts it to work?
Exactly. Training is the expensive, slow, data-hungry phase. Inference is the fast-serving phase, where the model takes your prompt, image, or audio and produces output.
Why should a regular programmer care? A lot of people just call an API and move on.
Because if you do not know which side of the system you are touching, you will make bad decisions about cost, speed, quality, privacy, and even what product is possible.
Give me a concrete picture.
Think of training like creating a game engine from millions of playtests. Inference is a player pressing jump right now. Building the engine is one problem. Running the game smoothly for millions of users is another.
That sounds obvious, but people blur them together all the time.
They do, and that confusion matters. Training changes the model's weights, its internal parameters. Inference does not change those weights, it just uses them.
So when I chat with a model, it is not secretly getting smarter from my one question?
Not in the usual sense. It may remember context inside the current session, or your product may log data for future retraining. But the live inference call is mostly applying what was already learned.
That already clears up one myth. What's actually happening during training, minus the math headache?
A model sees huge amounts of examples and keeps adjusting itself to reduce mistakes. Predict the next token, compare to the real one, adjust, repeat. Over and over, across massive datasets and lots of compute.
So training is like compressing experience into parameters.
Nice way to say it. The model is not storing every sentence like a database. It is shaping itself into a system that can generalize from patterns it has absorbed.
Let's do another example. Say I build a support bot for my SaaS app. Where does training end and inference begin?
If you fine-tune a model on old support tickets, that is training. When a customer asks, "How do I reset billing permissions?" and the bot answers in real time, that is inference. Different phase, different cost profile, different engineering concerns.
Cost profile feels like the hidden knife here.
Absolutely. Training often burns serious GPU time upfront. Inference can look cheap per request, but if your product scales, latency and serving cost become the business. Winners are often the teams that make inference fast, reliable, and affordable.
So the startup headline says, we trained a great model, but the product reality says, can you serve 10 million requests without melting your budget?
Exactly. Training gets attention. Inference pays the bills, or kills the margin. That is why model size, quantization, batching, caching, and hardware choice suddenly matter to application developers.
And this is where programmers can gain leverage, right? Maybe you are not training a frontier model, but you can still beat competitors on inference.
Yes, most developers will not train giant models from scratch, but they absolutely will design inference pipelines. Prompt construction, retrieval, fallback logic, streaming, guardrails, rate limits, and memory strategies.
Let's make that real. Say two companies use the same base model.
Company A sends huge prompts, waits 4 seconds, and pays too much. Company B retrieves only the right documents, caches repeated answers, trims tokens, and responds in 1 second. Same model family. Very different product.
So the competitive edge is not always who trained the smartest model. Sometimes it is who built the sharpest system around inference.
Exactly. And there is another reason to care: privacy and control. Training may require centralizing data and updating the model. Inference can often be shaped with context at runtime, which is faster and less risky for many teams.
Meaning, before you say we need to retrain, ask whether better retrieval or better prompts solve the problem first.
Yes, retraining is a heavy hammer. Inference time design is often the smarter first move. If the model lacks domain facts, add retrieval. If it needs consistent format, constrain the output. If it is too slow, optimize serving.
So, give me the clean takeaway. One sentence if possible.
Training teaches a model general behavior. Inference is how your product caches that behavior out, request by request, under real-world constraints.
And if programmers miss that split, they build demos instead of products.
Exactly. In AI, training builds potential. Inference decides who actually wins.